Video 235 Optimized Tile Setting Part 6. We have this GPU sync function that takes the inclusive bounds of the dirty rectangle region we want to update. Same names as the names right here, so you notice how this lines up nicely. And we need to get the WebGL context and the pixel array we're about to push up to, Pix2048, which stores the master memory for the game. It's a 2048 by 2048 texture. We need to convert the inclusive bounds of our dirty rectangle to a top left origin in pixels and a width and height in pixels. We also need a seek position in terms of bytes. So the offset in bytes to the pixel on the top left origin. So we need to take the Y origin, multiply by the width of the texture, and then add the X as a remainder. This gives us the position one-dimensional in pixels. We multiply by 4 to get the position one-dimensional in bytes, because RGBA, that's 4 bytes per pixel. So this position here is a one-dimensional byte version of this two-dimensional pixel coordinate. We're going to do text sub image 2D, which allows us to partially update a texture. It's a 2D texture with 0 LOD because we're not going to use MIP maps. Here's our rectangle. Here is the internal format of the texture on the CPU side. And here's our pixel array. Here is the offset in bytes. Here's where we're calling it from inside of the GPU clean it all function when we're updating the dirty dumb memory. And that's the tile memory we're updating, the dirty tile sectors on the master memory cells. We're also going to call it if the everything else cells have dirty sectors in them. And so it's the same exact call right here. Okay, let's go down a little bit further. Here's what we did previously, and here are footnotes for this video, and here's what we did in this video. You have been on the short playlist. If you want a longer explanation, go here. You can get the source code here, and you can email me here. You have been on video 235. Like, subscribe, and send me coffee.